Hi, my name is David Neubauer, and this is a screencast on the multilingualism of time, which is a sub-project in the framework of the Einstein Center Chronoi. I worked on this project for the past year, and in a screencast I'd like to tell you how the project went and what it is all about. We will do that in roughly 3 steps. First, there will be an introduction of a more theoretical nature. We'll ask what are time expressions and what is a temporal tagging. These are the main focuses of the project. Second part will be more hands-on. I will show you the demo application that you can also visit yourself. I will show you the project corpus, and I will also show you some evaluation numbers. How well does the application work with the corpus? And in the last part, we'll just have a short what's next, short lookout on how the project can be improved and what steps can be taken next. So the basic problem of temporal tagging or time tagging is identifying all the time expressions in a text. So in these 2 example sentences, we would have 4 regular time expressions. These are marked in green. And while this is a trivial task for a human reader, a computer only sees text basically and cannot really relate these time expressions. So the first step for a computer is to recognize these are time expressions, this is not normal text. And the second step then would be to be able to order these time expressions on a time scale. So for example, in this case, the time expression 15 years later would have to be normalized to a value of 1835 BC, and then it could be graphed on a time scale basically, and this would be the second step of the normalization of time expressions. We call these green time expressions regular time expressions, and this is because all the information that is needed to normalize them, all the information that is needed to order them on a scale is contained basically in their own numerical values. So 1850 is just the value on a time scale, and you don't need any further information than that. 15 years later you need a little bit more information, you need the anchor on a time scale, but it's basically just a numerical value. This is all different for a second class of time expressions. These are called temponyms, and for temponyms or named time expressions, we basically need some kind of contextual knowledge. So maybe have a look at the last example that reads the end of the old Assyrian period. To know how to map this expression to a time scale, to know the values of this expression on a time scale, needs knowledge, needs contextual knowledge about what old Assyria is and when this period ended, basically. So to summarize, we have 2 kinds of time expressions basically that we want to recognize and that we want to map to a time scale. These are regular time expressions and these are temponyms. Why do we want to do that? Why want we make this mapping to a time scale? Basically, this has multiple applications, multiple positive uses, but one of the most important ones certainly is search. So you could imagine searching for documents on the 19th century BCE, but both of these sentences here would not be marked as relevant for the search because none of them contains the words 19th century BCE. But a search engine that could rely on the prior work of a time tagger, of a program that finds and normalizes time expressions, would indeed be able to mark these expressions as relevant for search like 19th century. And building such a time parser that is able to detect and to normalize time expressions was precisely the aim of our project, the Multilingualism of Time. What you see here is the demo application of our time parser. This is a public web page. You can visit it yourself if you go to chronoi.test.idai.world, and there you'll find this little page. Yeah, you can choose one of the 5 project languages on the right, and if you want you can get a small example text for each of the languages, or you can enter text yourself if you want to and have that analyzed, but for this example I'll just use the English example text. I'm now sending that text to a server. The server does the time annotation, the time parsing, and this takes a while. I will not cut through this so that you get a good impression of how long it takes, but momentarily I think we should see the results. Yes, okay, there they are. As you see, we have the same text below that we have entered above, and some words are underlined, and these words are, some expressions are underlined, and these are explicitly the time expressions in the text. So we have 5th century AD and 1453, and you will recognize these as regular time expressions. If you hover over them, you'll get a numerical value for these, and we have a number of also underlined time expressions, and these are basically temponyms. So you have Roman Empire with a time scale annotated, and we have Ottoman Empire, late antiquity, Middle Ages. All of these were recognized by the time parser. Let's also try another language. I will choose the French example. This has fewer time expressions, but I basically just want to show you that it also works for different languages. Okay, we get this back, and it has 330 and 395 marked as regular time expressions, and there is Byzantin as the or a temponym marked up here. To properly test and evaluate the time parser, we collected a small corpus of archaeological journal articles. These are roughly 50 articles, 10 from each of the project languages, and we annotated a window of 50 sentences for each of these texts, and we marked up the regular time expressions like 1200 BC or AD 100 or 1980, and we also marked up the temponyms like formative period here or Tiwanaku 5 period. Another resource we created for the project was this list of temponyms, and these are period names extracted from the chronology database, which contains about 13,000 period names in total, and we were able to extract about 5,500 of them were usable English period names. We had them automatically translated and then manually corrected each translation to use these names in the time parser. So with the corpus in place and our parser in place, we can ask how well does the parser perform on our corpus of archaeological articles. We'll start with a precision evaluation. Precision in principle says how many of the decisions taken by our parser were right. So if our parser identifies something as a time expression, how often was it in fact a time expression? And we get these numbers for regular time expressions. These are 0.93, so 93% of the time expressions identified by the parser actually were time expressions. For temponyms in a narrow sense, we only get 0.47, but that is mostly due to the fact that temponyms in the broad sense were identified as temponyms, and if we count both types of temponyms, we get a precision performance of 0.88. The other evaluation question we can ask is, and this measure is often called recall, and this question just is, in the text in question how many of the time expressions were identified. So did our parser get all of the time expressions in a text, then it would have a performance of 1.0, performance of 1.0, and if it would have found none, then it would have a recall value of 0. Okay, so recall for regular time expressions is 0.87, which is about expected. So it's 87% of regular time expressions in the text were identified. Recall for temponyms in a narrow sense is 0.24, so 24% of all period names are identified, and temponyms in a broad sense is 0.05, so only 5% of all the named entities that can be dated were identified. In total, we think that these numbers are good exploratory results. For regular time expressions, the numbers are in the area of what we would have expected and what we also see from other corpora and other time parsers. And for temponyms, there really isn't that much of a basis for comparison, because temponym tagging has not been done that often at all, or especially not for a multilingual corpus and with our scope of temponyms. So with these exploratory findings in place, we can ask what is next for time tagging in the archaeological domain. What can we do next? What can we use this for? And we mainly see 3 directions. The first is increasing our resources, bigger corpora, better corpora, increasing our coverage of period names, extending the chronology database, for example, doing new translations of known period names, etc. The second direction, which is tied into that, would be integration and feedback. We can use this actually now and in search implementations to improve search queries. A good target, for example, would be journal databases, and we could also implement feedback mechanisms for users so that we could in turn increase our period name resources by this feedback. Another direction would be machine learning. We actually tried in this project to train a classifier for temponyms with mixed results. It didn't have the precision we would have liked, and it was not incorporated into the final parser. But with bigger resources, with additional resources, this might change, and it might be possible to train a sufficiently precise classifier. Our time parser is based on the Heideltime time parser, which you can find online at github.com/heideltime. It's open source software, and you can also find our parser there. It's at der-inst/heideltime. It's a fork of the official Heideltime repository, and you can also compare our work with the work of Heideltime to see what we added in order to improve the situation of time tagging for the archaeological domain. In closing, I hope you now have a better understanding of what this project was about and how the time parser worked, and I thank you very much for listening.